Welcome back to the second part of the third set of lectures. I'm going to discuss in this part the prisoner's dilemma, which is a problem that illustrates how egoists, both psychological and ethical, have great deal of difficulty in cooperating. And as I will also show a little bit later, cooperating through specialization and the division of labor is the foundation of economic prosperity. But people who are totally self-interest, act out of pure self-interest, have difficulty cooperating. I talked in the last part about some of the attractions of ethical egoism. Now I just want to review some of its weaknesses, some reasons why you might be a little suspicious of it. First thing to note is that any argument from psychological egoism to ethical egoism crosses the is-ought gap. Okay? That's because psychological egoism is an empirical theory and it says how the world is. Ethical egoism is an ethical theory. It says how the world ought to be, and how do you get from one side to the other. Okay? You can't just assume that. You have to make further arguments in order to respect the action-guiding nature of ethics. I also want to point out that Adam Smith's invisible hand argument is actually a utilitarian argument. It's not an ethical egoist argument. What it's saying is that everybody will be better off if we are all ethical egoists. Everybody will be better off, not natural, not just in the state of nature, but everybody will be better off within a market economy that respects private property rights and enforces contracts, and if it has a system of money, etc., then you can show, and I think it's called the fundamental theorem of welfare economics, that under conditions of perfect competition in a free market, then people's self-interested behavior will lead to the maximum amount of economic welfare. And we'll review that argument in a later chapter, quite towards the end of the course. But right now I just want to point out that this is actually a utilitarian argument. All right? It's not an argument for ethical egoism from ethical egoist premises. Ethical egoists also face a problem in interactions with other people because they're always willing to sacrifice the interests of others to further their own interests. Then they have difficulty with things like friendship, marriage, dating, all of these sorts of things, where people have to pay attention to the interests of their other people, of their friends. So this is the paradox of egoism, is that there are some really good things that are in people's self-interest, like having friends or having a stable love relationship. And if you are always guided by ethical egoist premises, like you should always act in your self-interest, you're not going to be able to access those goods, like friendship and marriage and stable love relationships, etc. And this is, in fact, what I'm going to talk about, the prisoner's dilemma, is actually a corollary of this idea. From the point of view of other ethical theories, there are problems with ethical egoism. A virtue theory would say that people who are ethical egoists are selfish. Principle-based theories would point out that ethical egoists would be really too ready to sacrifice the rights of others to further their own self-interest. Consequentialist theories would say that ethical egoists do too little to help other people. And from the point of view of moral standing, remember, moral standing is the issue of whose interest you have to consider. How can you justify the fact that only your interests count? How can you get other people to agree that that only your interests count? There's no morally relevant difference between yourself and other humans. For example, I'm tall, male, bearded, and my social security number is, social insurance number is ... These make me maybe different from you, but they are not a reason. They can't function as a reason why only my interests count. They're differences, but they're not morally relevant. And from the moral point of view of moral standing, you have to be able to point to reasons why one thing has moral standing and another thing doesn't. And the reasons that an ethical egoist can give are not very good ones. And finally, there's this issue of that ethical egoists have difficulty cooperating. And I'm going to illustrate that with the prisoner's dilemma game. It's in the textbook, but I'll work through a game a little more slowly. I assume that you are familiar with these games, but I'll just work my way through it for you so that it'll maybe help you understand what's going on. So the trouble with ethical egoists is that ethical egoists ought always to cheat to maximize their self-interest. And if maybe even if ethical egoism is not wrong, but if psychological egoism is true, then people will always cheat to maximize their self-interest. But sometimes cooperation maximizes their self-interest. So they can't cooperate. They'll always cheat, so they can't cooperate. And the classic example of this is the prisoner's dilemma game. So let's reason through a simple prisoner's dilemma game. This is one. Mike and Nancy choose simultaneously. If they both cooperate, then they each get 10, I don't know what, 10 utiles, 10 something. If they both cheat, then each gets 5. They want to get 10 rather than 5, so they'd rather both cooperate than both cheat. However, if one cheats and the other doesn't, then the cheater gets 15 and the cooperator gets 10. What will the two egoists do? It's based on the way that policemen sometimes deal with two participants in a crime. They take them in separate rooms and then try to get them to rat on each other by promising them a reduced sentence if they rat. They end up both ratting on each other, and these two, let's assume, egoistical criminals end up both going to jail for a longer period. Okay, now the thing about this is, looking at the game as described here, this description, you are unlikely to be able to solve it. And the trick, like any problem that you have to solve, is to find the best representation for the problem. And in this case, something called the normal form of a game is actually really helpful. You make what's called a payoff matrix, and in the payoff matrix you represent the two players, the two players here are Mike and Nancy. And you represent the payoffs that they will achieve by different strategies. They have two strategies, which is either to cheat or to cooperate, and Mike has those, and Nancy has those options. They can either cheat or cooperate, and they will get payoffs depending on what they do and what the other person does. And that's what makes it a game and makes it interesting to solve. And the payoffs are written in the upper right-hand corner of each cell of the payoff matrix. So, for example, Mike, who is the upper right-hand player here, his payoffs are in the upper right-hand corner here. So if Mike cheats and Nancy cheats, then Mike will get 5, okay, and Nancy will get 5, as it said in the original description. However, if, for example, Mike cooperates and Nancy cheats, then Nancy, here in the lower left side, because Nancy's here in the lower left, her payoff is here, Nancy will get 15. All right, so this is the way, this is the representation of the game. Now, the way you analyze it is you have to just proceed slowly and carefully through all of the possibilities. Some people, I guess, can see what's going to happen by just reading the description. I cannot. And if you cannot, then I sympathize with you, and I'm going to go through this carefully just so that you know how to do it. So the first question to ask is, if Nancy, who's here, if Nancy cheats, what should Mike do? Well, if Mike cheats, he'll get 5. If he cooperates, he'll get 2. 5 is greater than 2. Each one is trying to get the most for themselves, so Mike will cheat. Okay? And the same reasoning here. If Nancy cooperates, we're still wondering about what Mike is going to do, but we have to look to the case where Nancy, her strategy is to cooperate. What should Mike do? Well, if he cooperates, he gets 10. If he cheats, he gets 15. He's going to cheat because 15 is higher than 10, and the result will be that he cheats in that case too. So now let's put that all together into the original game. If we notice that if Nancy cheats, Mike will cheat because 5 is greater than 2. Okay, so let's circle that. And if Nancy cooperates, Mike is going to cheat also because 15 is greater than 10. So no matter what, and this is the key issue, no matter what Nancy does, Mike is going to cheat. Not every game will produce dominant strategies like this. If I rearrange those numbers in different ways, this wouldn't happen. But in this case, Mike has what's called a dominant strategy. He will cheat no matter what Nancy does. Okay, now that's important. Mike's going to cheat no matter what Nancy does. What happens from Nancy's perspective? What will Nancy do? Well, if Mike cheats, then we focus on this column here. What will Nancy do? Well, these are her payoffs here, and 5 is greater than 2, so Nancy will cheat if Mike cheats. What will happen if Mike cooperates? Okay, we're over here. Mike's strategy is to cooperate. What will Nancy do? Nancy, her payoff is in the lower left, right? She's in the lower left. So 15 is greater than 10. Right? I'm sorry, 5 is greater than 2, and 15 is greater than 10. Right? So no matter what Mike does, Nancy will cheat. Nancy also has a dominant strategy. And Nancy will cheat because her payoff if Mike cheats, 5 is greater than 2, and her payoff if, sorry, this little thing's coming on here, and if Mike cooperates, then 15 is greater than 10. So Nancy is going to cheat no matter what Mike does. Mike's going to cheat no matter what Nancy does. Put that together, and cheat is the best strategy for both. Okay? They'll both cheat because of their reasoning of the game. They're each ethical egoists, and they each reason that the other person is an ethical egoist too. But, and this is the crucial thing, cooperate is a better outcome for both because 10 and 10 are better than 5 and 5. If they could only get here, they could do better. But they can't get there because they're ethical egoists, and that is the trouble. In the terminology of economics, cooperate is a Pareto optimal outcome because both parties would be better off if they were here than here. Okay, now here's a question for you. Is this a prisoner's dilemma? So pause the video for a second, work through this, and we'll come back in just a moment and make sure that everybody understands how to work it out. Okay, welcome back. We've got a climate change deal, and the payoffs here are GDP gains. The two players are the USA and China, and they have two strategies, either sign or don't sign. And the question is, what should they do? Okay, well, if the USA signs this, commits itself to an accord, and China doesn't sign, then the USA payoff will be 200. But if the USA doesn't sign, when China doesn't sign, then the payoff will be 500. So the USA is going to not sign if China doesn't sign. Okay, so let's go back and ask, what is the USA going to do if China signs? Okay, China signs. We have to look here. The payoff for the USA is in the right corner. We're looking in this row of the matrix, and 1,500 is more than 1,000, so the USA is not going to sign. So the USA has a dominant strategy of not signing. Now let's look from China's perspective. China's perspective is if the USA doesn't sign, USA doesn't sign, what will China's best payoff be? Well, we have to look at these two payoffs because we're looking at this strategy here. China doesn't sign, they're going to do better here. If USA doesn't sign, China will do better by not signing. And if the USA signs, then we have to compare these two. And again, the China is better off if it doesn't sign. So these are the best payoffs for China, and China will be better off not to sign, no matter what the USA does. So the answer then is A. Yes, it is a prisoner's dilemma, and there's an equilibrium at the upper left, because these payoffs, 500, 500 in GDP gains, are lower than could be achieved if they both signed.